fixed today. Hopefully we've got it fixed now. We'll go ahead and get started um, because there's a lot to cover. Just now, like literally this instant, um, hang on, let me share Google Chrome. There we go. Okay, just now this instant got the lecture slides up on GitHub and realized I mislabeled them. It's called I labeled today. It's this one right here. It's called The Rest of the Semester, but it's dated the 26th, which is next Monday. Today is obviously only the 19th. But the file I just posted 1 minute ago called The Rest of the Semester is the lecture slides. You can get it. Just ignore the 426. I got that wrong. A lot of stuff to cover today because we're going to start wrapping things up, and that means a couple of big projects will be going on very close to overlapping. I'm going to start in a minute by going over test 2. In general, I was pretty pleased. There were 1 or 2 perfect scores. The average was in the fairly high 60s out of 75. A lot of you, I think almost all of you, are still in the A-B range for the semester. There's a couple in the C range, nobody worse than that. So I'm still pleased. I understand, it's a very difficult thing. You didn't sign up to go to college online. So I'm pleased with what's going on so far. We'll go through it. Project 2, we should be halfway through. It is due next Monday night. We'll talk about that a little bit today. I do want to briefly talk about classes and last week's lab, which I will give you an extension on. It's theoretically due tonight. I'll give you a few extra days. I have to wrap that up with the TAs. Tomorrow's lab, by the way, is recursion, which we've already done. So tomorrow's lab, you're not going to have any problems with. It's just making sure we get classes and last week's lab because I couldn't give a lecture on Wednesday because of the exam. That'll be fine. And then with whatever time is left in today's lecture, we're going to have our first bit on importing modules, importing code in Python, using all this gobs and gobs and gobs and literally terabytes of code that's already been written for you, and doing some pretty cool stuff with them. And we're going to be using what's called Jupyter notebooks. Used to be called IPython notebooks. Now it's Jupyter. That's going to be the core of Project 3, which is released next week. So I want to get you starting to think about that a little bit. It will be, as I said, assigned next week, and it'll be due the last day of class, which is Wednesday, the 12th of May. This is a tentative schedule. As of today, I reserve the right to change this if we're going faster or slower. You will notice, if you pay attention to what the majors are doing, that this is where we really diverge. This is where we really break apart from what the majors are doing and go into the stuff that I think is going to benefit you as non-majors, where you learn and use the computer science elements, but you actually use it in service of your own major, in service of your own area of study, rather than learning it because you need to learn it. This is not negative in any way, shape, or form, but the majors at this point are learning things because they need to learn them, because this is their first comp sci class out of however many they're going to take, 12 or 13, and they need to understand these topics. You, we hope, are going to learn these because they're going to help you in your career. They're going to help you, solve problems in your major, whether that be chemical engineering or music or economics. So we really break away. So I want to talk just a little bit about what we're going to do. Now, as I mentioned today, we're going to talk briefly about exam 2. We're going to talk a little bit about project 2. We're going to talk about classes so you can do the lab. And then with whatever time is left, I'm going to start in an introduction to importing and using Python code that's already written and using the Jupyter Notebook tool set to help you, solve problems using your Python coding skills. On Wednesday, which is the 21st, we're going to wrap up whatever loose ends we have from today And then we're going to talk about binary and hexadecimal numbering systems, base 2 and base 16. Computers don't really use base 10 like humans, and Python comes with a lot of built-in structures to help you with base 2 or base 16. So that's the gist of Wednesday's topic. Monday the 26th, next Monday, your project 2 is due at midnight that night, and project 3 will be assigned. As I said, project 3 is going to be, and I'll give you some examples, presuming we have time, of what students in previous semesters have done for project 3 for me. Again, with importing code, Jupyter notebooks, and graphics. Next Wednesday, which would be the 28th of April, we're going to start the most computer science-y topic of all this semester, which is different ways of sorting and searching data, and looking at what we call the algorithm analysis, the algorithm complexity. What's the fastest way to do something? What's the slowest way to do something? Worst cases, best cases. We're going to analyze, so it's not just solve the problem. It's going to be solve the problem in a reasonable way in terms of how long you're taking to do this, because the things we're going to be dealing with are all still fairly small data sets. But for example, my recent master's a few years ago at Berkeley in data science, we were, for one of our research projects, there's a group of 5 of us, we were tapped into the Twitter, was called the Twitter garden hose you can get for free. You can get 1% of all the tweets that Twitter puts out globally. Okay, 1% of all the tweets you can think of, you're getting billions and billions per second, and you've got to process them and look for things that what you're doing. And so it really matters if you're getting billions and billions of something, if you've got a fast algorithm or a slow algorithm. So that's what Wednesday the 28th, and I apologize, I just grabbed the wrong mouse. I got to get this desk organized. I've got 4 computers, 5 monitors, and 3 mice, and I'm grabbing the wrong one. Let's make sure this works. Okay. The following Monday, the 3rd, that's when I will assign you homework 6. You will have a homework 6. It will not be the same as the majors. Obviously, they've already had theirs. And we will finish up next Wednesday's topic, that Wednesday's topic of sorting and searching. And we'll dive more deeply into project 3, because I find project 3 is the kind of thing some people just get it, love it, dig into it, and get it immediately, and other people struggle, and we get them through it. Wednesday, the 5th of May, we're going to focus on graphics, because project 3, a lot of it is graphical analysis representing your research results. And then the last week, Monday the 10th and Wednesday the 12th. Monday the 10th, both your homework 6 and project 3 are due. Apologize for making you both do the same day. Homework 6 is really not that bad. And we will also talk about higher level Python topics, how to run an entire website in Python, how to do the kinds of things that all of these imported modules allow us to do. And then the last day of class is Wednesday the 12th. That's when your project 3 is due. That's our course wrap up and review for the final. And according to UMBC's schedule, the final exam is Monday the 17th from 3:30 to 5:30. It will be very similar to what you've seen before. It'll be on Blackboard. It'll be in class time. It'll be multiple choice, true, false, short answer, and programming. It'll be like the other 2, except it's going to be a little bit longer because it's worth more points. So as of today, that's what we've got left this semester. So now, before I get into classes, I want to take a real quick swing through exam 2. As I said, in general, I was pleased. A couple of things I want to point out. I'm going to go through this fairly quickly because, as you see, we've got a lot of material to cover today. First question, Python types covered in this class that are mutable are lists and dictionaries. Both lists and dictionaries are mutable. The others, int, float, strings, and booleans, are immutable. Yes, there are additional types that we haven't covered, and you were not responsible for them. You were warned multiple times that question 2 was coming. Nobody missed it, so I don't think anybody missed it. Test as you go. Write a function, test the function. Write a block of code, test that block of code. Don't try to do everything at once, or you're never going to find the bug. 3, multiple choice difference between opening a file for W and opening a file for A. They're both write only. You can't read from either one. The difference is if you open it for W for writing, it erases any previous contents, puts the file pointer at the beginning, and you're starting with a new file. If you open it for appending A, then it does not delete the previous contents. It puts the file pointer at the end and writes from there. So this first answer is the one that's correct. 4, suppose I had a dictionary and I said, I want to add the second New York senator, who is Kristen Gillibrand, to this list, and I do not want to delete Chuck Schumer, who is also a senator from New York. How do I do that? Of the ways I gave you, the only one that works is to turn New York into a list, which is perfectly valid. You can have lists as values. You can't have lists as keys, but you can have lists as values in dictionary. So that was the only way that would work. The others would not. If I went with this first one, it would erase Schumer, and the other two don't work at all. The 2D list in Python, it has R rows. Which one's a true statement? Actually, none of them are. The length of the list does not yield the number of columns. It yields the number of rows. Rows first. If you want to access the row I, column J, you use L sub ij. No, you have to have the two separate square brackets. It's L sub square bracket I, square bracket J, square bracket. And you can manipulate an entire column at a time. That's backwards. You can manipulate an entire row, not an entire column. So none of those was correct. If there's a return statement in a function, but it never gets executed, the function has no return. I apologize. That seemed to be confusing for a couple of students. If you've learned other language where other languages have void functions and things like that, where there is no return, in Python, if there's no return or there's nothing that gets executed, it returns the special value none of the special type none type. There is always a return in Python. If there's a statement that doesn't get executed and the function ends, it is you return none, not that there's no return. 7, I gave you a program that basically does some silly stuff, but I asked you what the parameter height in the function. Now remember, up here, these are the parameters. Down here, these are the arguments. So you had to know two things. You had to know that the parameters are the ones up here, and then you match up in order. And so height, the parameter height in the function call gets the second argument, radius, which is 4. Okay, so you should get the value of 4. How can you be sure a copy of a 2D list is a deep copy? You basically have to copy each element of the list separately. We did talk about list slicing. List slicing is a deep copy for 1D lists, but it does not work for 2D lists. If you try to list slice just the rows of a 2D list, you're not going to get a true deep copy. 9 was true. Yes, if it can be done with recursion, it can also be done iteratively. It may be harder, it may be less logical, it may be more difficult, but you can always do it iteratively. The reverse is not true. Okay, and 10, when you read in a file, everything is either going to be a string or a list of strings. That is true. 11 was a poorly worded question, and I apologize. I tolerated a lot in terms of grading. I think nobody lost more than 1 or 2 points unless you just didn't answer it. And again, never leave an answer blank. I'm generous with partial credit. What I was getting at was looking for using the get method. You could either tell me in prose, or you could write code that said I use the get method with some kind of error message that will cause the program to not crash because California is not there. That was what I was trying to get, but as I said, that's on me. I didn't word the question that clearly, obviously. So if you said, well, check to see if California is in governors.keys, you got full credit for that. That will absolutely work. Others of you said, well, check to see if Gavin Newsom is in governors.values. You could actually do that. That would work. And for those of you, who seemed not quite clear on it, I was generous with the partial credit. It wasn't the greatest question in the world. But what I was getting at is if you use the get method with the dictionary and the key is not there, the program will not crash. That's what I was looking for. You could also have an if statement that says if California's in governors.keys, or if Gavin Newsom is in governors.values, either one of those was accepted. 12. Write a Python function that calculates the volume of a right circular cone, which is V equals 1/3 H times pi r squared. I think pretty much everybody got that. There might have been a couple of minor errors. I think somebody left off the divided by 3. I think somebody didn't square pi. You were rushing. Yeah, that's not a big hit on the points. Let's see, 13 was kind of a silly program, but what I was getting at was scope of variables here. What I was looking to see was scope of variables. This is the main program. Okay. And in the main program, string is not defined. String is defined in the outer function. String is defined in the inner function. There is no string in the main program. So I get the error message because string is not defined, is out of scope. Anything like that was an answer that was acceptable. Excuse me, 14, we've done this before, but that's split and join to change, and there was actually a famous typo in computer security, cybersecurity many years ago. Somebody built something called the provably secure operating system, and it actually got typoed as the probably secure operating system, which made somebody's conference presentation paper not so good. But you could split this by words. You could split it on the spaces and split it into individual words and change. Remember, once it's a list, you can replace things. So you could replace the first word probably to provably, or you could split the whole things into characters and then split the fourth entry, sub 3, P-R-O, and then the next one is sub 3. Either one of those was okay. Just basically split it into either words or letters, replace the one that's the problem, and then join them all back together with nothing in between them, just an empty string dot join, and you're good to go. And pretty much everybody got that one. The 2D list was something that we'd actually done in class a couple of times. People got that one. Again, I think there were a couple of minor issues people had, maybe lost a point or something, but it wasn't bad at all. The 2 programming questions, I have a file, cities.txt. It's in the directory. Don't worry about it. It's the 10 largest cities in the world, according to Wikipedia. Read them all in. A couple people, some people, actually more than a couple of people, lost points. Remember, these all get read in as strings. So you actually have to convert all of these values from strings to integers to add them up and get the average, to add them up and get the mean. A few people lost points for not converting, this to an integer, because these are strings. And if you remember, if you use plus, if you add strings with a plus sign, it just concatenates them all together. It doesn't give you the sum of the integers. You need to convert to integer. That was a 1 or 2 point mistake. Other than that, people pretty much got this. And that was, like I said, pretty much straightforward. The last one, 17 was the one I was a little harsh on grading. Again, most people got it. Write the recursive function that determines the number of characters in a string. What a number of you did not consider that the string could be empty. The string could have 0 characters. So if you gave me a solution that worked for any string that had 1 or more characters but did not work for an empty string, I took off 1 point. And yes, I acknowledge taking off 1 point for something that didn't work for an empty string was a bit harsh, but it was, it was just something that to me was kind of glaring. But in general, I was pleased. Most people got that or got most of the points. The base case, when I did this, my solution, I used the base case was it's an empty string. If the length of the string is 0, or if the string equals the empty string, whatever, I return 0. And my recursive case was I added 1 to the string with 1 element chopped off. You could chop off the last element of the string. You could chop off the first element of the string. Either of those works fine. Add them up. So as I said, by and large, I was pleased with the grades. There were 1 or 2 perfect scores. There were a bunch more. The mean was up there toward the mid to high 60s. Right now, as I said, with the grades still to come, so a lot of points still out there, but I'm pleased. A lot of the grades are running in the A or high B range, and a few of you have C's. Don't worry about it; you're doing okay with that. But you have to keep it up there. You have less room to slide with projects 2 and 3. Like I said, the one question I acknowledge was poorly written, so I was the one about the governors was poorly written, unfortunately. So it made sense to me, but that's okay. I think weirdly. So I was pretty lenient on grading that one. I don't think anybody lost more than 1 or 2 points if they answered it. The big thing is, and I know timing, you get frustrated or whatever, please don't ever leave an answer blank. If you leave an answer blank, I can't give you any partial credit. It's just, no points for that question. If you give me a decent shot at an answer, even if you're maybe a little lost, but you got a good start, I can give you a number of points, and these things add up. If you have questions about it, we'll take that after class. We need to move on. That is test 2. Like I said, the final is Monday the 17th of May, and it'll be similar. Let me go ahead and close that tab. Project 2, thank you to the 2 students who pointed out I had made an error. Let me go to GitHub real quick. I posted, so this has been corrected on both GitHub and Blackboard. I posted an incorrect file originally. The fall 2022.csv and fall 2023.csv files were identical. It was just 2 copies of the same thing. I have no clue how I did that. That has since been fixed. The fall 2023.csv file that's on GitHub and on Blackboard, doesn't matter which one you get, they're all the same. That has been fixed. Now, there are no changes. There's nothing else. Just basically, if you haven't done this between last week and today, when you have time, go to either GitHub or Blackboard, get this fall 2023.csv file, and use that instead of the old one. I kept the name the same. Nothing else changes. The way you can tell it is correct is the one you're supposed to use for fall 2023. All the students in the class are characters from the TV show The Big Bang Theory. Yes, I am a geek. You do that. So fall 2023, they're all characters from The Big Bang Theory. Fall 2022, they are all Nobel Prize winners in either physics or chemistry. If you're curious, you can look them up. And spring 2023, they are members of the United States women's national soccer team, or the team that won the last World Cup. I suspect they've changed a few members by today. But to make sure you've got the 3 files, the data files correctly. Fall 2022 is the Nobel Prize winners in physics and chemistry. Spring 2023 is the soccer players. And fall 2023 is the characters from Big Bang. And those are the 3 data files. Now, project should be straightforward. You just read these 3 files in. Each of the 3 files, you read them in and you convert them to a 2D list. They all have header lines that you have to read in and throw away. For instance, they have, I believe all of them have 2 header lines. Class, identifying which class it is, and the one that says this is the student name and these are all the columns. So you're going to have to read in 2 lines and throw them away. We've talked about how to do that. Once you've done that, then you just convert this into a 2D table, a 2D list, a table. How you do that depends on whether you use read or read lines, your choice. If you use read, you just split on the new line characters. If you use read lines, you have a 1D list of strings, and then you split those strings should be on the blank space in between. And I warn you that down at the bottom, a couple of these files may have some extra lines, some extra spaces that you'll have to get rid of. You'll have to have some code that throws away a couple. Don't worry about that, until you get there. You should by now, 1 week into the assignment, 1 week to go, you should have no problem getting all 3 of them into the 2D lists. Once you've got that in the 2D lists, what you do, sorry, clicked the wrong button there. What you do with the description is that you add some things. You total up the 3 project grades and add a column with the project score. You total up all the semester grades and add a column with their semester total. Then you add a column that says whether they got an A, B, C, or D. Okay, then the second part of that of the assignment, the second big part of the assignment is once you have these 3 lists, you now write a user interface and let the user search for students who may or may not be there. And you have to, validate the user input and determine if the student is there. And if there's a conflict, for example, in this Big Bang Theory characters, if the user searches by last name, you have Sheldon Cooper, you have his mother, Mary Cooper. So you've got a conflict. You're going to have to be able to, let the user say which one of these 2 I really want. Student IDs should be unique. I use some random generation software to generate those, so they should be unique. You should not have any conflicts there. And then you're just gonna, in your user interface, you're gonna tell the user what they want to know. Sheldon Cooper was a student in fall 2023, and he got an A. So it's fairly long. I mean, project 2 is fairly long, but each step should be fairly straightforward, which is why I wanted to give you this assignment rather than, write another game. We did write a game for project 1. That's fine. It's a good thing to do. Never criticize what the majors do. But to me, it seems more logical and straightforward rather than writing another game to write something that you can actually see how it's going to be used. And as I said, if we have time when we talk about project 3 later today, 3 is going to be kind of the same thing. So that is project 2. Make sure you do it. TAs are up to speed on it. Make sure you're making progress. Don't wait this for the last minute. If you have any questions, let me know. If you discover any other errors here, let me know. Like I said, it was good that I was told that I had posted the wrong file and had 2 copies of the same thing and plenty of time to fix it. Okay. Let's start talking about last week's lab, and then we'll figure out how much more time I have to give you to do. Like I said, this week's lab, tomorrow's lab is recursion. It's pretty straightforward. You shouldn't have any issues doing it. I've talked to Kevin and Mariah, and we're going to make sure the lab stuff is. Okay. So classes, objects, object-oriented programming. What the heck is this stuff? I mean, they're buzzwords. Everybody's got buzzwords about coding. I write a class, I write methods, I do object-oriented programming, I build objects. What is this? This is nothing but an abstraction. It's a notion, it's an idea that makes programming easier. Instead of having to write pure, bare naked Python and functions and code and build things from just the Python spec, it lets you use higher level concepts to build things that make the code easier to understand. The big thing we want to do as we get into more and more complex coding is make things easier to understand so that we know what we're doing and have fewer bugs. When there are bugs, we can understand them and other people can understand our code, fix our bugs, and continue to use it after we're done. Okay. These are just things that help programmers think about programming in terms of a natural object, an object that may exist in the real world that has properties that you can think of. I mean, not everybody has a car, I get that. But a lot of people understand that, there's this thing called a car, right? And all cars have engines, and they have different types of engines. And all cars have a maximum speed they'll go. And cars are all evaluated and rated by how much fuel they consume. If it's a gasoline-powered car, it's how many miles per gallon they get. If it's an electric car, it's how many miles you can go on one battery charge. It has a property like the number of seats. I mean, you've got the little sporty two-door convertibles, and you've got the little four-seat thing, and you've got the, the family minivan, right, with 7 or 8 seats. So these are all things that a car has that you can describe the car. And then once the car is in motion, you may care about who's the driver or who are the passengers, who's in what car. Let's, get this done. So rather than think about naked Python as I want to implement, a load management system for Uber or Lyft, and I have to write Python from the beginning, what you want to do is set up these abstractions, these programming abstractions, to let people think of, I'm going to get a car, and I've got passengers in a car and driver. And that's all I have to think of. I don't have to think of while loops and for loops. I think of, how do I add passengers to a car? Does the car have enough gasoline? Is the electrical charge sufficient for this trip? And it makes it easier to deal with. That's all this is. It's just it's a programming paradigm that theoretically makes programming a lot easier to do. If you really, really are into this, CompSci 202, which is taught in C++, is heavy into object-oriented coding. You'll get all you want there. Sign up for it. I think it's great. Okay. We're just going to give you the intro to it. So we want to implement these objects, and this is what Lab 10 is all about, to make programming easier. Now, object-oriented classes are different in every flippant programming language. And I got to be honest, classes were not an inherently important part of Python. Python was just not inherently an object-oriented language like C++ is, like Java is. And so Python does support the abstraction, but it's a little bit different, and it's a little bit clunky, and it's not always, it's ingrained. But that's okay. I mean, you could do a lot of programming in Python without ever getting into classes, and most people who program in Python don't get into classes. But it's an important computer science concept, so that's why we include it in this class. Now, as with anything in computer science, the first thing you have to do is you have to define a class, okay? And so we'll switch to PyCharm, sorry. Could not think of that word. We'll switch to PyCharm, and we'll start defining a class. Now, from the lab, which is Professor Hamilton's structure, we'll go with that. He says, we're going to talk about cars, right? We're writing a load management application for Uber or Lyft, or the next competitor to Uber or Lyft, your own little UMBC ride-along app. So we'll say class cars. Now, in this case, cars, and I think I'm being consistent. Let me go back and double check with the lab. I've got the actual lab here. Hang on. Just want to make sure. Oh, he calls it car singular. Okay. All right, here we go. He calls it car singular, so let me do that. Now, if you had a longer title than car, it says in the lab the syntax we use is upper camel case. Upper camel case is, let me put this in a comment, we would use class big honking pickup truck. This is what's called upper camel case. Camel case, now remember, variables, we use snake case. Snake case means underscores joining each word. Camel case means we don't use underscores joining each word. We run the words together and we uppercase the beginning of each word. It's sort of like the humps on a camel is what this is called. And upper camel case means the first letter is uppercase, rather than that would just be camel case, upper camel case as we start like this. This is our syntax that we normally use, but of course this one, like I said, for the example in the lab, all we've got is a single word, so we're fine. Now, so that's our car. So that's our class definition. That's our name. Now, what is it that we have as part of a car? In this case, in the example lab, we have to say this next line, def underscore underscore init underscore underscore self, says these are the things that make up a car. It's going to have a make, a model, a VIN, a vehicle ID number, and a license plate. Okay, now I'm going to skip ahead. This is this is the lab assignment. This is the first example. I'm going to skip ahead to the one that's more useful. Okay, as soon as I can find the thing. Okay, what I'm going to do is init is how you actually create one of these instances of this car. And it's going to have the parameters. Now, in this case, what I'm showing on the screen right now is his first example in the lab, where he defines them in the class constructor. He automatically says, this is a Toyota Camry with this vehicle ID number and this license plate number. That's not useful. What we want to do is we want to define it to let's define the class constructor such that a person can define any make and model he wants, and we do it this way. Let me get rid of those things. I have no idea why I put the parentheses there. Okay, so just like with an if main, this is 2 underscores. Now, self is a reserved word, and all it means is the name is going to be assigned later. The name is going to be assigned later. Whatever name it is assigned is going to replace self here. Here's the parameters it's going to have. It's going to have make, it's going to have model, it's going to have VIN, and it's going to have plate. Okay. Now we have to say what those are. So we have self.make. Let me get my syntax correct here. Yeah, self.make equals this variable make. So what happens is what the user passes in as the make is going to be assigned here as part of the, it's going to be made part of this object of this class. Self.model is going to be equal to model. Self dot, I can't spell self right, VIN is going to be equal to the VIN, and self dot plate is going to be equal to the plate. What this means is when the user creates a car, the user has to pass in these values, make, model, VIN, and plate, and then one of these car things will exist. Okay, and so that's where he's got here the line. Let's just take that straight to pie chart. Now the user can call car and create a car with, that's a Toyota Camry with this VIN and this license plate. Okay. And the user can also create another car that's a Honda CR-V. Okay, and so this is just, these are just examples of creating a car. You call this with Toyota Camry, this VIN, and this license plate number. Remember, these are matched up in the init function. The init function is reserved for how we create one of these. Toyota gets matched to make, Camry gets matched to model, VIN gets matched to this string, plate gets matched to this string. Whether these are numbers or letters, I don't care. I'm not going to do any math with the vehicle ID number. So we're just going to treat them all as strings. Okay, and so that's how we create an object that's part of this class. Okay, Now the user has to know this, but this is part of programming, is making sure that giving the user enough help and enough information that the user knows what he has to do to do it. Now, if you want to use this, now the next part of the lab assignment talks about inside the class and outside the class. When you code one of these things, you have some functions and some code that operationally is all bound in together with the object. It's an internal method. It's a method for accessing an object, and it's defined and it's built in there. Okay, and so that's what the lab refers to as inside, is if you're writing code that goes inside the whole class definition thing that says, this is what I want to do, then that's accessing inside. If you're presenting to the user this class, this object of what is a car from the outside, then we're referring to something called outside, and that's what part 1C of the lab talks about. So part 1C of the lab says, okay, I am some other part of the program that's going to talk about a car. Well, what I need to know is the variable name that is an instance of these. Well, up here, I defined my car as a variable that is an object. It's an instance of class car, and it has these specific values. Another car is a variable that is an object that's an instance of this class car, and it has these values. So now if I want to access the subfields of those, I have to give the variable name and the specific field name. I have to know that in order, these are make, model, VIN, and license plate. Okay. And so that's what's going on here, is this first print statement takes this variable, my car, and says, get the make, that's this first field, get the model, that's the second field, okay, and print those out. And then here, go to variable make another car and get the make field and the model field. So from outside the class, the two things we need to know are, what's the variable name that is an instance of those? Well, it's defined as my car, and it's defined as another car. Those are the two variable names. We also must know the names of the four fields. The names of the four fields are make, model, VIN, and license plate. How did I know that? They're what's defined here: make, model, VIN, and license plate. That's what I need to know when defining a class and accessing it. So now I can do whatever I want. I can get the value, I can print the value, I can add, I can subtract, I can do whatever is a meaningful operation with the individual field. Okay. And he gives you in the lab assignment, there's a couple of examples. There's no such thing as mileage, right? Even though cars have mileages, we did not, in our class constructor, we didn't define mileage. We just defined make, model, VIN, and license plate. So when I try to access mileage, and there's no such thing as mileage, I get an error message. And this is the particular error message that Python will give you. It's an attribute error because Python knows this is a class. Classes have objects. Objects have attributes. The subfields are called attributes, so it's an attribute error, and mileage isn't defined. Okay. And so if you want to rectify this, then it means you either left something out of your object definition and you have to redefine it, or it means you need to just not worry about mileage. If you're doing inside a class, again, you're writing more functions. The only thing we've written right now inside the class is how to create one. But we can also do other things like how to add passengers. So for example, in this case, in the lab, what Professor Hamilton did, these are this part of the lab assignment is exactly what I did. He called it license plate instead of plate. I'm lazy, guilty. He added another field called passengers, and passengers are not passed in. And he defined passenger as a separate pass. Okay, so let's go ahead and make those changes. This now becomes part of the class definition, we will have a list of passengers, one or more, and then we have another class definition, go back and make sure here, called passengers, that said a passenger is referenced by his or her name. Okay, a passenger is just a name. So that's my passenger definition. Okay. Now, we're going to add a method. We're going to add a function to our definition. We can do this, which is going to be add passenger. And add passenger, remember, passenger up here is a list. All add passenger does is it appends a new name. It appends a name to the passenger list. So this is another function defined in the class. Okay. Now, as he points out, everything has self. Remember what self is. Self is a reserved word that says to Python, the name for this is going to be added later. Use it to reference this object whose name will be provided later. For right now, it's just a placeholder. Okay. And he gives an example of calling a couple of lines of code to add himself as a passenger to the my car, which you have to come after my car because my car, if you put this code right here above this line, my car won't exist, and so that won't work. So you have to do this. Here, remember that a passenger is a class, which is just a name. It's a string. That's all it is. In this case, this passenger is represented by the name Eric, and calling add passenger, which is the function defined right up here, just says add Eric to the list. The list was initially null. It was an empty list. Now the list has one item in it. So then you add passengers and go on. Okay. The rest of this, I'm already after 4:45. Okay. The rest of the lab assignment talks about adding checks. This is important when you do the lab assignment. Make sure the same passenger can't be added to the car twice. If you have a maximum number of passengers, which we do not have a maximum number of passengers in this definition, you could put one in. You could say, you know, is the car already full? If you have an 8-passenger van and you already have 8 people in it, giving somebody else a ride home is a bad idea. It's actually illegal. Part 1E talks about simply adding another variable MPG and then figuring out how much gas you have and how far you can go, creating the method fill and drive miles. Skip 1F. If you're really into it, go ahead, but I recommend you skip 1F for now. It's not necessary for the assignment. What I want to do is talk about the specific part that you have to do in your lab. Okay. You're going to create 2 new classes. You're going to create a class box, which has 3 instance variables, length, width, and height. And then you're going to implement a class called item, which has its own length, width, and height. We're not going to worry about rows, height, width, you know, will things fit? It's kind of going to be a simple Tetris game of, is there enough volume left in a box to put a new height, a new item in? Okay, so let's get a little bit of a start on that. Let's come on down here. And so we're going to say class box. Boy, I'm typing terribly today. Okay. Def init self, and it's going to have height, length, and width. Now, the starter code for this is available on gl.umbc.edu, so you'll just have to fill this in. You won't have to worry about everything. But self.height is going to get the height that's passed in. Self.length is going to get the length that's passed in. And self.width is going to get the width that's passed in. And so that's how you define a class box with 3 instance variables, length, height, and width. Now somebody will create a box, give it a name, and it will and will tell you what the height, length, and width of that box is. Now you need another class, item. Now, because of scope, because of differences, you could reuse height, length, and width, but let's not. Let's try to make this clearer. We're going to say for item, def, pardon me, let me fix a typo. Up here, I only have 1 underscore. There needs to be 2. Okay, init, underscore, underscore, self, item height, item length, item width. And now we can say self dot item height equals item height. Self dot item length. Why can I not spell length today? Okay, and now we've defined an item, a class item, with its own height, length, and width. Okay. Now, so ignore the packing problem. Items should have a name as well. So if you want to put item name in there, okay, let's go back to that and say self.item name equals item name. Okay. Most of this is in the driver code, which he provides from the GL. You just have to download and do it. Now you have to write a method in the box class called place. Place takes an item and puts it in the box if there's enough space and rejects it if there's not. Okay, so what do you have to do to make this work? You have to track how much space is in the box total. Okay, how much space is in the box total is easy. It's its height times its length times its width. Once a box is defined, it gets a total volume right there. Let me look something real quick. I have this in the slides or not. I put out the slides. Sorry, I just realized somebody put something in chat. I haven't been looked at. Okay. Let me check real quick to see if I have this. Instantiation. Trying to make sure I cover everything I've got. Skeleton. Map to the variables, accessing the variables, methods, define them, class car, add a passenger. Okay, now that's it. So let's go back to pie chart. Just making sure. So anyway, so the volume, you're going to need a function, a method for box. The volume of the box is height times length times width. That's set. Once the box is created, that can't change. Now, you need to have something that keeps track of, you can either keep track of how much empty space is left or how much space is filled. Either one, right? Either, you know, space is either filled or empty in the box. If the box has a total volume of 200 and it has 50 in it, then the empty space is 150. So you can either keep track of how much empty space is left, or you can keep track of how much space is filled. Either one, that's straightforward. When someone wants to add an item to the box, you have to calculate the volume of the item. To calculate the volume of the item is simply you multiply the item height times the item length times the item width. Now, in the instructions here where it says don't worry about placing problem, if you know, this is really not truly a game of Tetris, because you know, maybe you've got enough volume but it's the wrong shape, right? Maybe your empty space is 2 feet wide by 1 foot high by 10 feet long, which is a total volume of 20, and you've got something that's 5 feet high by 4 feet wide by 1 foot long. Now, practically, you know, 2 by 1 by 10 and 5 by 4 by 1, that's not going to fit. It's simply not going to fit. It's not the right shape. But in this case, that would be okay, because we'll allow this because you've got a total volume of space available of 20. You've got an item of 20. And so that way, the importance of that instruction is just check the volume available versus the volume of the item. You don't have to check each dimension, height, weight, and length, height, width, and length, to make sure that you have, you know, the right shape to fit. This is not truly Tetris. If it's the right volume, it'll fit, and you know, we'll make it fit. That's all you have to do on this assignment. So going back to it, that's basically what it is. There is a remove method that just takes the item and removes it. Remember, items have names. So remove takes the name of the item and removes it from the box if it's in there, and just contain the item. And as I said, the driver is there. Here are the commands that you'll find in the driver. You just have to go ahead and write the code. It's fairly straightforward. And like I said, theoretically, this lab is due tonight at midnight, but since we did not have a chance until today, and even today I'm kind of rushing through it, I will give you an extension until Wednesday night, the 21st, for lab 10. For lab 10, I will give you to Wednesday night. I will ping Mariah and Kevin as soon as we are done and let them know that if you need more time, don't take too much time for the following reasons. Number one, you get to drop 2 lab grades free. Remember, there are 12 labs. We're only going to count 10 of them. You get to drop 2 lab grades free. Number two, labs are only worth 10 points, and you got 2 of them for showing up with your TA when you were supposed to. So we're only talking 8 points, even if you have to count this one. So make a good effort and get 4 or 5. I will give you until Wednesday. I'll take care of setting up GL and Discord after this class. And so you'll have that time to do that. And Kevin and Mariah will answer questions tomorrow if you want to work on that. But they're going to introduce Lab 11, which is recursion. So since you've got Project 2 and it's a big one, do this lab because it is an important concept to know down the road, but don't spend a whole lot of time on it, because for our assignments, you will not have to use classes and objects in Project 2 or Project 3 at all. You don't have to. You can, but you do not have to. So basically, it's get this lab done to the best of your ability by Wednesday night, and we'll move on from there. And I typically do not ask any questions about classes on the final, although you can ping me in May and ask me about it. I typically do not. There's so much material to cover in the final. And yes, in response to the question in chat, it is cumulative. That there's usually not room to throw a class question on there. So get it done. That's about it. Let's see. So that's all I want to say, because I'm down to 15 minutes and I've got another whole part of the lecture I want to talk about. This last 15 minutes will be spent just giving you a heads up of what's coming in Project 3. Okay. The background to Project 3 is that one of the big advantages of using Python for whatever you want to do your programming in is that there is a ton of code that is already out there that is freely available for your use. Okay. There is an entire math library of built-in functions, and I've included links to them, which I think are correct. They were correct as of 2 weeks ago when I put this together. where you can go and download this library, and that will tell you all the functions that you could use. You don't have to write a calculate the median routine. It's there. You don't have to write any, fancy math routine. It's there. The next one on this chart is called NumPy, N-U-M-P-Y, NumPy, not Numpy. NumPy contains a whole lot of code that does a whole lot of linear algebra and numerical analysis methods. Okay, it has all kinds of code. We've talked about lists are not truly arrays. They're not truly matrices. They're sort of, kind of, but they're not quite. What NumPy does is it provides codes where you can actually talk about an array in the context of a mathematical two-dimensional array. As I said, it contains a ton of linear algebra code. If you're looking to solve a system of n equations and n unknowns, there are routines in NumPy to do it. FFT is fast Fourier transform if you're into physics or something like that, and you need to do Fourier transforms to calculate various quantities. All that code is already written for you. You can just download it and use it from NumPy. If you want pretty good random number generation, NumPy has routines that will do that. You just specify where you want the, what range you want the random numbers in, and what kind you want. That's already there. Pandas stands for panel data. If you're into data science, data analysis, there's a ton of stuff in pandas. Like, for example, CSV files. Now, I force you, because I'm harsh, to read in a CSV file the hard way using straightforward Python read and break things out by new lines and commas and what have you. Pandas contains a whole bunch of software that already reads in a comma-separated value file and puts it in a data frame for you to start analyzing. A whole lot of other data analysis and data science code is in there as well. Pillow does a lot of image manipulation. If you want graphics, if you want pictures, you want whatever, the Pillow code is there. There's a bunch of stuff that does plotting and graphics. Matplotlib or Matplotlib, depending on how you like to pronounce it, has a whole bunch of graphical code and plots. ggplot and plot9, which we will probably use, has a bunch more code, and there's a ton more. So there is a bunch of Python code out there, and as part of Project 3, we're going to go get some of it and install it in our program and run it. You can import any of those into your Python program that you want to use. So you don't actually have to write a routine that calculates the statistical mean of a data set. That's already done for you. The nice thing about this is you can also import any other code you've already written yourself. Now, we're going to talk about this more next. Looking at I've got my calendar on my whiteboard. We're going to talk about this a lot more next Monday. We might talk about it Wednesday, but I doubt we'll have time. We will talk about this more on Wednesday. Once you have written the code yourself, you can import it into any other project, and we will work through some examples. I'll just show you today, and we'll talk about details. I just want to get you familiar with what's coming. If the package is already installed on your computer, and I'll tell you how to determine it is, all you use in your Python program is the import statement, import math. Most Python distros come with the math library. You just import math. If you wrote the Hailstone program for one of the homework assignments and you need to use it for something, you just import your own Hailstone program with an import statement. You're good to go. As long as it's in the same directory, as long as Python can find it, you can import that module and you don't have to write it again. So that's a cool feature of Python. The basics, if you want to import the whole library, your statement is just import math. And then whatever function you want to use, you have to say, okay, from math, I want to calculate the sign. So I just say x equals math.sign of whatever the sign of 0, for example. By default, sine, I believe, works in radians. You can also specify in degrees. 0, fortunately, is 0, so you get the same thing. You can rename this, and as I said, we'll get into it more on Monday. I want to move ahead. I just want to let you know that basically this is the idea that we're doing. There's a whole bunch of code out there that already does things, and we will install them in our code and do some things. This is an example of importing your own code, which we'll get to. What I want to talk to you now, because this is important for program 3, we're going to use something called the Jupyter Notebook. It used to be called the IPython Notebook. It's a format for producing a document using markdown language, and I'll explain that in a minute, and executable Python code and code results. So if, for example, you are doing a research report, right, and you have collected data, and you need to analyze data, and you want to prepare your report for your professor or for your job, and you're going to say, okay, I have analyzed this data, and I've used my Python skills that I learned from 201, and here is what you get. If you have the professional version of PyCharm, you can get the professional version of PyCharm for free as a student with your .edu email address. I know Kevin talked to you about that, those in his class. If you don't have the professional version, if you have the community version, this is not supported. We'll talk about how to do Jupyter Notebooks there that way. But if you are, if you have the professional version, then running a Jupyter Notebook is fairly straightforward. You simply say, I want a new project. Okay. Tell your computer, tell PyCharm where you want the project. Now, what I want is going to be a virtual environment. Now, this is actually lab 12, so I don't want to jump ahead too much, but these days, nobody runs any code directly on their computer hardware. It's inefficient, it's insecure, and you don't do it. What you do is you virtualize your computer system. You have software that runs directly on the hardware that makes it seem like you're actually on hardware, but you're really not. You're in a virtual environment. You're on a pretend processor with a pretend printer, with a pretend screen, with a pretend network connection that's all managed for you. And this is all called a virtual environment, not directly on the processor on your Mac or on your Windows PC. The reason you do that is because it's inefficient to dedicate one Windows PC to just you doing your homework. I'm sorry, but that's, you probably spent way more money than you needed to. And then especially in the professional world, you don't want to spend that much for something that doesn't get used that much. So everybody runs on the cloud or runs on shared hardware and virtualizes it and provides a pretend computer for which your program runs. So when you're doing PyCharm, when you do Jupyter Notebooks, you run in a virtual environment. So when you select when you tell PyCharm new project, you make sure you tell it, give me a new environment using virtual env. Those are your choices. You don't want to use pipenv or conda. You want to use the virtual environment. And like I said, this is actually lab 12 next week. This is where it is, the path on my Mac, for example, right now. This is which interpreter I'm going to use. I'm going to use the Python 3.8 interpreter. I've actually got a bunch of different ones on my Mac because I've been using it for a few years now, but I'll use 3.8. I'm going to inherit global site packages. I've got to make this available. And this will create a brand new Python project that I'm going to run in this window. Okay. And this, while this is creating, will let me get started.
Doug, where are you?
All right, hurry up, or I'm going to have to switch back to the one I've already done. Okay. All right, hurry up. Okay. Now, let me go to when I set it up earlier. If I can find it. It's in PyCharm projects. JN project. Okay. What I did here is once you've created this new project, you click on this plus sign right here, and that you create a new IPython notebook, .ipynb, and now you can just go ahead and add things to it to create your program. Yeah, new. So it's file, new, Jupyter Notebook. Give it a name. Jupyter Notebooks are called .ipynb, or IPython notebooks. And now I can start running. Now, what does this look like since I'm down to my last 5 minutes? I'm going to show you. I've been teaching this class. This is my third semester. Dr. Susan Mitchell used to teach it. She retired, and I inherited it from her. And she used to do weather data. And I said that was kind of okay, but I wanted to do something more complex. So the spring of 2020 class did COVID data. So what they did was they fetched data from the Johns Hopkins COVID data site, and they downloaded it and they analyzed it, and they showed trends of, at that time last spring, where COVID was heading, where it was growing, where it was shrinking, how the US was doing compared to other countries, things like that. In the fall, I had them, since the elections were topical in the fall of 2020, I had them fetch data on elections, historical data on US Senate elections, download it. Now, what you're seeing here is that this is actually Python code in a cell, and it actually runs and produces results that we'll look at. And see, markdown is this text. This is just a term, think markup, markdown. This is text that tells what the research results are doing. For my class, for project 3, I didn't require much, but think about using this for a chemistry report or a physics research project or an economics project, right? And this is where you're having your text, your explanatory text with all kinds of bold italics and whatever you want. And then you have the actual cells that produce Python code, and then you execute that. So you can show in your report the code that you ran, and then when you execute it, it provides the results. So in this case, I had them do, this is next week's assignment, sorting and searching. I had them figure out how long it took to actually sort the election data. And I compared it with several other things. Then this is I had them print out some of the data they had fetched, the Arizona Senate results, the California Senate results, and what have you. And I had them just show Democrats, Republicans, and the 2 independents who've actually won, Bernie Sanders and Angus King. And they ran through and showed all the candidates and how their vote totals went and everything else. And so, for example, you could see that in West Virginia in 2018, Democrat Joe Morrison beat Republican Patrick Morrisey, 288,000 to 269,000. As I said, it was topical, so I had them do senators. And then we started producing graphics. Okay, and the graphics are various things. These are importing this statement right here, the plot9 library. We import these functions. And then once we've imported these functions, this is the actual Python code that produces this graph from this data. And then there's some more results, and tell me what this data means, provide more analysis. This is a different set of results on how Democrats did year over year, state over state. the total number of Democratic votes, and so on. This is one student from last semester. Like I said, I had the ones I'll show you later. This is running out of time. From last spring was COVID data. So what we're going to do with Project 3 is this. You're going to install and get familiar with Jupyter Notebooks. You're going to download and use the modules I'll tell you about. And we're going to download data and do some analysis just like this. You'll do some number crunching, you'll do some data analysis, and then you'll produce a variety of graphics, and then you'll basically present a research report that tells me what you've got. So this is my view of Project 3 for the non-majors course. Is it something that, to me, is more directly useful in your academic career, which is not a negative or criticism over anything else over what the majors are doing, but the majors are at a point where they're taking their first class and they need to learn how to do object-oriented programming because they're going to use it for the next 20 classes. Whereas I want you to learn something that takes the computer science principles and the Python skills, and then you can use it to improve your performance in engineering, economics, music, or whatever. So what I wanted to cover today with this and what I have done is get you prepped for the assignment that will come out next Monday, which is Project 3, which is we will get a data set that I'll tell you all about, and you will install Jupyter Notebooks, and you will download and install the modules that I'll talk about, and you will do your analysis code. And as I said, typically there's always, everybody likes pretty pictures, so I'll have you produce some graphics, but there'll also be another analysis. What I wanted to make sure today, so this does not hit you as a surprise next Monday when Project 3 comes out, that you're ready for this and you're going to be able to deal with it. So that's what we did. We had a very busy class today. I went over exam 2. If you have questions, let me know. I went over a little bit about Project 2 and pointed out the correction. If there's anything else there, let me know. I talked about classes. Hopefully you can now do the objects, the classes lab 10. I'll give you till Wednesday night, but again, don't put too much time into it because you get to drop 2 labs anyway, and it's only worth 8-10 points at this point. So the recursion lab tomorrow you should have no problem with. You've already covered all that recursion, and Project 3 is coming. If you have the professional edition of PyCharm, which you can get free as a student, you will have Jupyter Notebooks built in. If you do not have that, you don't have to get it. I'm not going to force you to. We will talk about how to run Jupyter Notebooks separately, independently from PyCharm. It will work. You don't have to do it. That is the end of a very busy lecture. If you have any questions, I'll hang around for a little while. And other than that, I will see you Wednesday with a more traditional, straightforward binary and hexadecimal processing lecture. Thank you.
No questions, but thank you, Professor.
Thank you.